Sushruta for NEET is now available on the Google Play Store. Try it out for free.
So we are now going to continue our the start of the new section of the class 12 material, and I'm going to start with first a understanding of force, a little bit of Gauss law, and then how to study the material so that you become successful with respect to understanding the problems. Now, the material around electrostatics, right? Well, so sorry if so. The aim of today is to kind of get everyone readied up to understand how to study using our platform, and we're going to today start the class 12 material. Okay, so for class 12, let me bring up my slides to kind of explain where we're headed with this. Okay. So, as you know, this is a new year, and our platforms Sushruta for NEET and Ramanujan for JEE are now available, right? And they're available, and we are starting a new promotion because it's the new year promotion, right? Between the new year and the harvest festival, be it Pongal, Shankranti, Baisakhi, etc., we have a promotion, and so this is your perfect time, and it will go on till the end of the festival. So festival promotion, common, right? So and so this is your perfect chance to buy this program. Okay. So we have Sushruta for NEET, Ramanujan for JEE, and so you download the program first, try it for free, and then use it. Okay. If you are in a school which we support, right, and now we are continuing to support a lot of schools, then you can talk to your school to get your program, and maybe it comes for you for free. But let me explain how you study using our apps. Okay. See, when you download our app and then you register, you will face these kinds of screens. Okay. Now, these kinds of screens typically what they provide you is they provide you in context learning. Okay. Now, in context, what does in context learning mean? So if you have a book, right? Research tells you that ebooks, people learn less from ebooks. From the garden variety vanilla PDF based ebooks. Okay, they learn little better from actual textbooks. And let me I always start with showing students concepts of physics by Professor H.C. Verma, right? So we advise students to to use our books in the following way. Okay, so we start with the syllabus, right? So you go to the syllabus. So let's say you are studying today's material, you attended this lecture, and you want to brush up and learn about electrostatics and Gauss law. So you bring up the physics, go to physics, and then you go to the particular unit. When you go to the particular unit, then you can go to the textbook, the particular section in the textbook, the particular videos, the particular slides, etc. And so that's the mechanism you have. Then when you bring up the textbook, you will get the same set of icons. Okay, so let me go over the icon. This icon, Moodle icon, is when your school is affiliated with JnanaMarga and they have specific content, you can go and look at that content. Okay, so that is also in context modal content. Okay, the second kind of content is the videos. So let's say you're learning Gauss's law. You want to see the IIT PAL professor's videos. Let's say if a particular material is tough. Let's say you find Gauss Law tough. Then you go and see. It's fantastic. I have seen all those videos. Professors' videos are very good. So you see the videos. Our slides are derived from those videos. So you have the textbooks, see the videos, go back to the textbooks. See the videos, go back to the slides. Read the textbook, go to the slides. So your effort is to wrestle hard with the material. Do some of the problems in the textbook. If you have typically we recommend people having 2 books, particularly if you're going for JEE or NEET. We recommend that you buy a copy of H.C. Verma on top of the NCERT textbook. NCERT textbook is very good, for physics. So then what you do is we also reference. You can reference the particular page in the H.C. Verma book, okay, and you can read that too, okay. So you wrestle with the material. Spend, let us say, 1 or 2 days learning very hard the material, okay. Then you look at the solved problems in H.C. Verma, okay. But then eventually after two days, every now and then you must go and click the assessment, and you don't want to take the you want to take the generic assessment, which will go to other sites. There may be like some other there are so many 10 to 15 sites which provide questions. You can try some of those questions, and then the aim of self-assessment is not to hurt your ego. The aim of self-assessment is to assess if you've understood. The aim of doing problems in H.C. Verma, right? So in H.C. Verma first book 2, right, is for class 12. So the first few sections deal with heat. Now the section that starts with electricity is this one. Okay, what is electric charge? So it's chapter 29 H.C. Verma, and corresponding chapter is in your NCERT book. Okay, so learn from both. And in H.C. Verma you look at the solved problems, very good solved problems. Then you do the problems in H.C. Verma. Okay, so then first do objective type. Okay, because your first exam is JEE Mains. So once you get through that and you use the assessment as well, then after some time you must do the questions in your NCERT book and also the questions in H.C. Verma, and then you must build your knowledge, and you must, if needed, for in the questions in H.C. Verma, you can go and see if someone solved it in the internet. Okay, so you must have a notebook like me. Okay, so when you study, you have a tablet or cell phone, and then you have your online book, and then you have your H.C. Verma. Okay, now you made a significant investment. You bought a cell phone. You're using parents' cell phone, right? And and you're studying, and you're studying hard. Okay, so study and study and study. Okay, so when you get sometimes parents' cell phone, you may not be able to access. Then you have to read from the book, and study hard, and so learn the material very well, and then and then you rely on these various things. Rely first on the videos and the slides. Always look at the slides. If you want quickly to learn, read the book a little bit. If it's too difficult, go to videos. If videos is too difficult, go to slides. Then watch our videos. Okay, so I always make videos. We have a full go to our playlist, and then go to the playlist and then learn from the lecture there. If the material in the IIT PAL is tricky, the material in IIT PAL is not tricky. You have to listen carefully to the lecturer, and you have to invest in it. It will take 45 minutes to listen to a full lecture. So that's why we recommend that if you have Wi-Fi, you switch to Wi-Fi instead of using air connection. Okay, so when you do the YouTube, go to Wi-Fi. Okay, when you download the slides, it's fine, but when you do YouTube, you must definitely go to Wi-Fi, because you don't want to waste air time is very costly. So you must have Wi-Fi And I don't know if you can get a phone yourself or tablet yourself and work with that. And so in some states now they are giving tablet, get it. Ask if you have to apply, right to the government, get it. And try to speak to teacher. I want to study hard, so they should try to help you also. So in person, these are the things you must follow. Use the assessment, use the YouTubes, use the slides. These are and use the textbook, video, slides, assessment, textbook, video, slides, assessment. And if your school is affiliated with us and they are working, then you will find some material if your teacher has added some material. Use the voice search if you're suddenly you want to know what is a Gaussian surface. Go there and say voice search or type it up, Gaussian surface. Go look it up in the. It will take you to a particular page in the book. And then also use Wikipedia. Wikipedia is a very nice resource. So just go to Wikipedia and ask Gaussian surface. You will understand a lot also from Wikipedia. So then once you've fought the material, you've read the HCR, you've done the questions, now you're ready. So this is a tricky effort. As people go to Kota and learn, right? I know, people go to Akash, they go here, they go there, but this is the low cost way to do it. Okay. And this is the way to do it when you're sitting at home. There is no travel, you don't have to drive. Or when you're driving, let's say you're going to Akash, you've signed up with Akash, going to Akash, in the car if you have a tablet, you can learn. Okay. So that's the model we have. Or we have a cell phone. Okay. That's the model we have, but we must wrestle with the material. That's what we want. So this is the formula sheet for electric charge. So this is, I'm assuming this is the second time you're learning this. What I described was the first effort, right? So the second time you're learning this, you can go and look at the formula sheet. What is Coulomb's law? Q1 Q2 by R square. K times Q1 Q2 by R square. K is 1 by 4 pi epsilon naught, right? So see, there you have K, right? And so then you have this one, right? Electric flux. And then Gauss's theorem. Flux is equal to Q by epsilon naught, right? And and then you learn all this material. So you have the charge force equation, then you have potential, then you have electric field and the relationship between electric field and potential, and then you have the work done by when you move a charge from one point to another in the electric field. Okay, so these are all the related ideas. So first you must learn all these individually. Then you must, when you see this sheet, you must relate all these ideas, and then because that's what you need to solve problems. Okay, so the slides they are like this. What is conservation of charge? You all know that charge can either be created or destroyed, and it exists. It's seemingly lost and regained, right? But then it always exists in some sense because the electrons and protons remain, right? And then we have subatomic charge, conservation, and quantization of charge, right? Ionized particles have lost electrons, but the electrons are there somewhere else, right? And so electric charge is quantized. The charge of an electron 1.6 × 10⁻³ minus 19 coulombs, right? And so if you have a cube of copper, 2 to the power 24 electrons. So there is conservation of charge, there is quantization of charge, and there is the additivity of charge, right? Then we introduce the material, right? Now there are conductors which allow the free flow of electrons because of the if you learn the material later about particularly in chemistry why conductors have you will understand the free electrons where they come from, right? Now insulators, they don't allow flow of electrons. They are high resistance, and some of them they don't allow any flow, any electron. Glass or plastic is very typical. Plastic. Why do they put a plastic around the inner metal, right? Inside, typically copper is used, right? Copper is a conductor. Most metals are conductors. Otherwise, they will use some kind of aluminum maybe sometimes. And so then around it they put plastic. Now then there is this new the third type of elements are called semiconductors, right? Then Coulomb's law, K Q1 Q2 by R square. Force is as always a vector, and Q1 and Q2 are the individual charges. R square is the distance between them. Okay, so and K is 1 by 4 pi epsilon naught, right? 1 by epsilon naught and epsilon R, right? So that's how this works, right? K force is 1 by 4 pi epsilon Q1 Q2 by R square, and R hat is the unit vector. Okay, so unit of charge is the Coulomb, and electron charge 1.10 to the power minus 19 coulombs, right? So 1 Coulomb has this many electrons. Anyway, so this is kilo everything, right? So principle of superposition is that the force due to two, if there is a charge Q1 and the charge Q2, then and then there is a if there is a force between them, and if there are two forces, then it is additive, right? So it is an addition of two vectors, though, right? So if you have two charges, then you have a summation of two vectors, right? So the Coulomb's law provides the force, and the force is if like charges repel, unlike charges attract, right? So if we have large number of charges, there are only two types, plus or minus. So and therefore 1 by 4 pi epsilon naught Q1 Q2 by R square, and that R hat is a unit vector, the line joining the two charges, right? So that is the basics of electrostatics. Now, when you look at the net force, you then do a vector sum F1. So if there is two charges Q2 and Q3, and what do they do to a charge kept at the origin, then they will have a addition of two sums. Now, along with the force, with Coulomb's law, we also introduce this thing called an electric field. So if you have a unit charge, what will a unit charge experience at a particular point? So you have an electric field at every point, which is the force that a unit charge would experience, right? Force per unit charge is the electric field, right? So it is F by Q. If F is equal to Q1 Q2 by R square, K Q1 Q2 by R square, F by Q will give you the electric field, okay? Force per unit charge. So now here's a question where he's asking where is the net charge 0, right? So if you look at it, net charge will be 0 along the line connecting these two, right? So if you look at the addition of two vectors, somewhere along the line only both of them will completely cancel. If you take other points out here, etc., it will be next to impossible to make them cancel. So it's possible maybe along the line joining the two of them in some places, but I don't know. Mostly it is in the line connecting Q1 and Q2 that you will find places where they completely negate each other. So where is the net force on Q3? 0. Probably you will get 1 point here and then 1 point here. Okay, based on where Q1 is bigger or Q2 is bigger. Otherwise, you will get 1 point here and then 1 point here. And so to the right of Q2 and between. So you'll end up, when you solve the equation, 1 by 4 pi epsilon Q1 Q2 by x square equals 1 by Q1 Q2 x minus 1 square. Then you will end up with, you solve a quadratic equation, right? And when you solve the quadratic equation, he gets x minus 1 by x equals plus minus half. Then he puts plus half, he gets one value, puts minus half, he gets another value. Therefore, using these two, you end up with these two values. Therefore, that's how you end up with results. The x components additive, y components negate each other. So electric field, like gravitational field, every charged body produces an electric field, every point around it, and E magnitude is what a unit charge would experience as force in newtons per coulomb, right? So Coulomb's law is pretty straightforward, okay? And you can solve any number of problems with Coulomb's law if you understand force and you understand basically Coulomb's law, okay? So that's all you need to know. This is all you need to really know, but then you should always solve the problems in concepts of physics. H.C. Verma, you always solve the problems in your, go to the app and solve the problems, right? This one, click the Q, question mark, solve the problems. Okay. So now once you've done this, you've understood principle of superposition, understood how vectors are added. Remember that electric force is much stronger while gravitation is much weaker, right? And therefore, you then understand electric field, which is the force experienced by a unit charge. And if there are multiple charges, what is the field at a particular point is again a superposition principle. Just add the vector addition, right? Now, inside an electric conductor, there is no electric field, and this is best understood by learning about Gauss's law. Okay, Gauss's law helps you calculate its closed integral of E dot dl is the flux. E dot dA is the flux. Closed integral of E dot dA of a surface over a closed surface equals Q by epsilon. That is Gauss's law. Okay, and therefore you should understand that closed integral of E dot dA equals Q by epsilon. Understand Gauss's law and all the full import of Gauss's law. If you do understand the full import of Gauss's law, calculating all these electric field problems, not at all difficult, but you must understand the field theory associated with it. And field theory is, there are vector fields, depends on positions, electric fields. Therefore, they draw these field diagrams. Let's also understand how these field diagrams are drawn. You go from a positive charge to a negative charge, and you have more lines. That means if the electric field is more intense. Okay. Therefore, then we introduce the concept of a dipole. A dipole is given as the 2a times q, right? And so when we use that dipole, right, we then took 2a times q will give you the dipole, where a is the distance between the 2a is the distance between the two charges, right? So it is a vector, goes from one to another, right? So and then the electric field produced by the dipole, then you have this concept of P cross E, right? So so understand these details. Understand what a dipole is. What is the dipole moment, right? Dipole moment is Q times 2a, right? Therefore remember that in a atom there is a dipole because there is a small thing called the nucleus, of course much bigger than the other thing called the electron. And if you think of assume that the electron is a particle, remember there's a dual theory, right? Then you have a dipole, right? Positive and a negative, right? Particularly in the case of hydrogen, there's one positive, one negative, right? In the other cases, there's a cloud, right? There are multiple electrons floating all over a very big space, right? And therefore, because of that, it's a combination of dipoles, right? So understand that. Okay? And then remember that if you take H plus and O minus, then you also have a second kind of dipole, two dipoles. You can think of the what is that? Water molecule also has possibly two dipoles, right? Dipole is a uniform. When you put a dipole uniform electric field, you have one being pushed and the other being pulled. Therefore, you have a torque, and the torque is P cross E. Okay, and so learn this carefully. Solid angle, and then you come and solve some of these problems. Okay, so I am going to do some of these JEE problems quickly today, but then remember the process you have to use. You have to learn the material first, little bit read the material, watch the videos, look at the slides. Watch the videos, look at the slides, can do a little bit parallelly, but try to do very good justice. Keep a notebook like me and note down what the professor is telling when he is talking, right? Note the main formulas. Some of them will be there, are there in the slides, right? Then look at these slides. Okay. Sometimes I enhance these slides and I add these extra questions, etc. And that is because when I make the lecture, I want to explain to you all these other things. Okay. So now, then once you've learned this material, then you can do these problems. Okay. So a hollow metal sphere is charged such that the potential on its surface is 10 volts. The potential at the center of the sphere is what? Okay. Remember that inside a charged sphere, there is no electric field. What does that mean? It means E is equal to dV by dr, right? Potential is Q by 4 pi epsilon naught. dV by dr E is equal to 0 inside the metal sphere, and that comes from Gauss's law. And so as a result, inside the sphere, the flux will be, the potential will stay constant, because E is 0, dV by dr equals 0 means V is a constant. So if it is 10 on the surface, then it will be 10 completely inside. Okay, so if it's uniformly charged sphere, 10, the potential is 10 on the surface. Inside also it will all be 10. Potential will all be 10. Now, as you go outside, you are enclosing a charge, and therefore, as you go further and further away, you will have Q by epsilon coming in. E dot dA equals Q by epsilon. So the bigger surface that you build, the lesser the potential. Closed integral of E dot dA will apply there, because there is a Q enclosed. The Q enclosed is the total charge of the metal sphere. Okay, so that's the important idea here. If you understand that, you understand this, what we are trying to teach here. Okay, so this is very critical material, and you must understand it in terms of the what we are trying to teach. Okay, so now this is a question about capacitors. So sometimes if you learn only little pieces and you go and study capacitors, you know, you will find, oh my God, electric charge is this question, why am I struggling? You know, you should assume that you have to learn more material. You find a difficult question like this, or it's you know, not you know, you haven't learned it, then it means that you have to go and study that particular material, you know, and you invest in that material, you know. So now you have to watch more videos, you have to read more chapters, and you must read solve problems here, you know. So there is a certain, what they call tapasya, you know, there is a certain penance, and when you do that little bit of penance, after 2 days you will be able to solve this problem also, you know. So, but I'm teaching you about that. No, I'm not laughing at the problem, you know. I have been through this, you know. If you think you know everything, then it's very difficult. You don't know is a good thing. Don't know, you must go and learn, you know. That's why we have the app, you know. Then you go to the corresponding chapter in the you know, in the app, you know. Go to physics, go to the particular chapter. Maybe it is not electrical, maybe it's another chapter. Go through that chapter, learn the material, and you will be in far better shape. Listen to the related lectures, read the textbook, read the corresponding chapter in H.C. Verma, do 1 or 2 problems there. Then you can come and solve these problems. It will not be difficult at all. Always a you're building your conceptual basis. Okay, if you know only Coulomb's law, you'll struggle. If you know Coulomb's law plus Gauss law, then you will struggle less. You know, if you've not understood Gauss's law, do both. You know, and you must know it well. Then once you've done justice to both, then these problems become easier. So that's why you have the notebook, and you invest in listening to the lectures, learning the material, structured approach to studying. Very, very critical, notably in electricity magnetism. And of course, all the force material as well, you know. So, and if you don't know this force and vector addition, which we always teach at the beginning of the course, then that will also become a headache. So, learning all the material, building your understanding base, physics is very conceptual. Physics requires calculus, it's also very conceptual, you know. So, you learn both, and then you slowly build your base, and you will do well. Okay, so but structured approach, without structured approach, if you don't know something, go and learn that something, you know, and you build that you know, you learn more. Each question is teaching you. Okay, a parallel plate capacitor. What is a parallel plate capacitor? What happens to, what is potential? So first you learn about charge, Gauss's law, then learn about potential, electric potential. Okay, so once you've done justice to charge and electric potential, then you can do justice to capacitance. Then you can do justice to current. Okay. Then you can do justice later on, if you understood this material very well, to semiconductors. This is about 30-40% of the physics paper. Once you do justice to these 3 or 4 topics, then you will also, the material in modern physics, very critical. You should spend a lot of time there in learning everything that happened. Then you have covered sufficiently and with a lot of inner honesty the material in physics. Physics is a conceptual fight, so understand the material carefully. Okay, so that is my key advice. So I would skip this question if I only looked at this chapter. So I'm not going to, I'll discuss this when we come back later. Okay? But then I introduce this so you know. So now this is a more straightforward question. Okay. 3 charges, Q, Q, and Q, capital Q, small q, and small q, placed in the vertical isosceles triangle. The net electrostatic energy of the configuration is 0 if Q is equal to what? So electrostatic energy is what? Electrostatic energy is the potential times the charge. Okay, so U is QQ by 4 pi A. Q1, Q2 by 4 pi A or R. Okay, is the potential between 2 charges. Okay, so if you add these 3, right, and it's a scalar, QQ by A, QQ by A, and so you will then end up with 3 equations. There are 3 different electrostatic energies. One between these two, one between these two, and one between these two, right? And then you sum those 3, right? And it is a scalar sum, right? Then you set the whole thing to 0, QQ by 4 pi epsilon naught A, QQ by 4 pi epsilon naught A, QQ by 4 pi epsilon naught A, root 2, and then Q square by 4 pi epsilon naught A, the third one, right? So you say, and he's saying where under what circumstances is it 0? It will be 0 when Q is some ratio of the little q, and big Q is a ratio of little q, right? So then you kind of do the algebra. You set that to 0, U equals 0, and you do the algebra. So now this question, the first question was looking at seeing if you understood force. This question is looking at seeing if you understand electrostatic energy, and then in between the two there is potential. So yeah, force, field, potential, and energy. And when you understand force, field, potential, and energy in the context of a capacitor, then this question comes into play. Okay, so then you can look at force, field, potential, and energy inside a inside a parallel plate capacitor, then you will understand the material in that context. So this is another capacitor question. 2 identical plates are given positive charges Q1 and Q2. They are brought together. The potential difference between them is what? So this is actually a much trickier question. Unless you understand how to rework this, it is not easy at all. Okay, so we will discuss this when we discuss capacitors again. Okay, now let's look at this one. Okay, this one introduces all the things that you learned in this chapter. 2 point charges Q and minus Q are held at a distance. So you have the axis Q and minus Q, okay, respectively. So plus Q is here, minus Q is there. Okay, the electric field at all points on the x-axis has the same direction. Well, it has the same direction if you say this way and that way is the same. But at this point it will be this way, at that point it will be that way. So it, strictly speaking, doesn't have the same direction here and here, right? Because they're both held in the x-axis. So in some of these points it will point that way, some of these points point this way. So they will have change direction. So from this direction, it will go to 0 at one point and it will go to change direction that way. Electric field at all points on y-axis is along the x-axis. So if you place a unit charge in the line perpendicular bisector, right? So this charge, let's say you place a unit charge, it is going to be like this. The force will be like this. You place that charge, the force will be like that, right? And the uh, but the magnitude of those two will be the same, right? And so it is a geometric question, right? So you have the line F1 and F2, right? So the y components will cancel, okay? And at any point on the perpendicular bisector, which is the y-axis, right? The y components will cancel, and the x components will be, one will be like this, and the other will be like charges repel, unlike charges attract. So because one is plus q and the other is minus q, one will be like this, the other will be in the same direction that way. So when you have two charges like that, the x components will add up, the y components will cancel. So hence it is B. It's a very simple question. Okay, work has to be done bringing a test charge from infinity to the origin. No, the origin also has zero potential, infinity also has zero potential. So there is no net work actually. It's a very tricky question part. C is very tricky. Dipole moment is 2qd along the x-axis. It is 2q times 2d. Okay. Q, 2a is the distance, minus q plus q, right? He's saying the dipole moment is along the x-axis. Yeah, right? Yeah, dipole moment is along the x-axis, so it is minus q at right. So the answer is B. And 2q times d along the x-axis, or is it minus 2q times d? Right. So because it is. See here, by convention, it goes from here it goes from minus q to plus 2, right? The plus x direction. So actually, this one is plus q and minus q. So it goes from the minus to the plus, right? So here it goes from the plus to the minus. So it is not along the plus x direction. It is along the x direction, but it is along the minus x direction. It is so. Maybe D is also true, right? So probably your answer is both B and D. I don't know, right? So so you could say D as well, right? But definitely it's B, right? So my 4QD is not correct, So all right. So it is 2QD, right? And so it has in terms of the directions, it is from the negative x direction. Along the x-axis is correct. It is the negative x direction. All right. So with that, I'm going to close. Not careful, like I wasn't, you will get it wrong, right? So, so electric dipole. Try to understand also the electric field due to the dipole and what happens. The field due to a dipole is along the I direction. Okay. So so understand electric dipole and then go from there. Okay. So these things are worth learning well, so invest your time and effort in building a significant knowledge base So you understand electric fields, okay? Then you understand Coulomb's law. So now let me bring up this Coulomb's law. Not Coulomb, Gauss's law, right? So that we quickly cover that ground also. Okay. So Gauss's law, so this was, again, we showed this, right? Now, so we saw all this, but then we looked at potential, right? See, potential is the work done, just as force is the field is the force, electric field is the vector and the force experienced by a unit charge. Potential is related to work. Is the work done to bring a charge from infinity to a point. So potential at a point is a scalar, is the work done to bring a unit charge from infinity to that point. Therefore, it is q by 4 pi epsilon naught, or due to a point charge. Now, if you had some kind of continuous thing, then you will do a integration to find the charge. Now, the work is also a line integral E dot dl. Okay, the work done ends up becoming a line integral, right? So, so given that, and then you divide by the charge, and therefore you end up with E. So this is your work done by the force to bring it from Ri to Rf is V of Rf minus V of Ri. Okay, so E is equal to QE naught I, right? And therefore QE naught times I. All right. So now when you look at remember, understand the path independence of work in electrostatic potential, right? So you can go in many different ways, but it only depends on the endpoints, right? So you may remember that if you listen to our previous discussions, right? Then you need to understand Gauss's law. Flux is closed integral of E dot dA, closed integral of E dot dA equals Q by epsilon. So you must fully understand Gauss's law, and then you must understand electrostatic P. So once you understand these three concepts, then you have to understand, from having understood these three concepts, then understand capacitance. Okay, then capacitance will make a lot of sense, because if you understood these three concepts very well. Okay, and therefore there is the integral and differential form of Gauss's law, right? Gauss's law is closed integral E dot dA equals Q by epsilon, or or as in the differential form, which is Maxwell's equation, del dot E equals rho by epsilon. Okay, now, and that if you use divergence theorem, then correspondingly you can change the integral form to the differential form. It goes from the differential form to the integral form. Del dot V dot dV equals V dot del dot E dot del dot E dV equals E dot dS, right? So that is the divergence theorem. Now, using divergence theorem, you can go from the differential to integral form. Not important if you are really for high school, but we just teach it a little bit as to why they teach it in two forms, why Gauss's law is taught in two forms. Mainly, you understand this surface, understand the idea of a Gaussian surface, closed integral of a Gaussian surface, theory around it, fluid flow theory, flux theory, etc. Okay. So, having explained this, why I did this in this class in this kind of haphazard way was to explain that you have to learn several related concepts in order to be able to attack the problems associated with electrostatics. You have to understand the 3 or 4 related ideas, and you have to be able to apply them in great and careful ways. So first you do electrostatics, electric potential, and Coulomb's law, Gauss's law, and electrostatic potential. Understand those ideas. Then you come to capacitance. Understand the ideas in capacitance. Then you will be able to solve most of the problems involving electrostatics. Electrostatics is not difficult once you have a good basis in force. You understand force vector addition. You understand which is a vector, which is a scalar, and then you understand capacitance. Okay, and then you understand these 3 laws, and then you understand capacitance. Then electrostatics kind of falls in place for you, but you must do a lot of problems. Students who do a lot of problems in master electrostatics put themselves in a very good place when they need to take the either NEET or JEE. Okay, so and then you do well in electrostatics, you do well in electricity, you do well in semiconductors and modern physics, then you're very well set with your class 12 material. You know, I assume you have spent significant time with the mechanics. If not, we'll continue and pay careful attention to the what we teach in the class 11 lectures. They happen Friday. So I have not. I've taken a few weeks off from the class 11 lectures after we wound it down, but now I'm going to restart, and I'm going to your class 11 lectures will start again next week. Okay. So, but the class 12, see, this is where I wanted to start. I want you to know how to solve these problems. Now you have to emphasize a lot of time, in both, and this is how you study this material. Okay. Do the significant investment in the lecture, significant investment in the slides, significant investment in solved problems, significant then learn all the material. Okay, then significant investment in solving the problem. Keep a notebook, have the formula sheet. Okay, then you make a significant interest in solving your own attempts at these problems. Don't go to the problems and learn from the problems unless you've done justice to all the material around it. And that's you do when you invest in the associated IIT PAL lectures in the app. Okay, so this is how you study using the JnanaMarga method. Okay, and this is particularly useful for what we've done with physics. Okay, so with that, I'm going to close today's lecture, and we will again look at proceeding further with this material starting next class. All right. So with that, I'm going to close, and then I'll see you all again.